the t results. We looked at the double angle results. I like to think of the t results as the half angle results. It starts with this idea. We just let t equal tan theta on 2. That's what it's going to represent. Now we know the double angle, because theta is double theta on 2. Therefore we could write this as 2 tan on 1 minus tan squared, but replace that with t. And what it ends up doing is turning this trig expression into a polynomial. And that can sometimes be easier to work with as far as factorization and things like that. Well, if I know tan theta is there, so opposite over adjacent, bit of Pythagoras, we can work out the hypotenuse. It turns out to be 1 plus t squared. That means we can create the t results for any of the trig ratios we like. So yes, tan will be 2t on 1 minus t squared. Sine now turns out to be 2t on 1 plus t squared, and cos 1 minus t squared on 1 plus t squared. So there's our 3 main t results. Now, of course, it doesn't have to be tan theta. If I was to make t representing tan theta, then actually we get the double angle results and things like that, because there's tan 2 theta, which we know is 2 tan theta on 1 minus tan squared theta, but as far as a t result goes, it'll be 2t on 1 minus t squared. I mean, it could be, if I'm playing with 4 thetas, I might let t equal tan 2 theta, and I can use the t results for that. And that's why you think of these things not as 2 theta results and theta on 2 results. Think of them as double the angle or half the angle, whatever you're working with. I want to double it, I want to halve it. So in that case, tan 4 theta would be 2t and 1 minus t. The t result doesn't change. All right, let's play with some. We're going to show this expression, but notice they need to define what t is going to be. So if they want me to show this as t, we need to know, well, what's t? T in this case is the traditional tan x on 2. Okay, we'll sub in the t results. And we can use the t results because x is double x on 2, or if you prefer, x on 2 is half of x. So yes, I can now use those t results for the sine and the x. And the beautiful thing about it when you're using it for cos and sine is the denominators are the same in both fractions. So they will cancel out nicely, and we don't have fraction on a fraction. If I multiply top and bottom by 1 plus t squared, tidy it up, 2t squared on 2t, well, that's just t. We've proven what they want. We're going to use t equals tan theta on 2 to simplify this expression. 2 tan 75 on 1 plus tan squared. We notice it's not the double angle result, because the double angle result would be on 1 minus tan squared. I guess that's why they're giving us the hint there, use the t results, because that is the t result. In that case, that must be representing tan 75. So tan theta on 2 will be tan 70 on 5. In other words, theta is 150 when I work this out. So 2t on 1 plus t squared, I know that's the t result for sine theta. So really I'm saying, what's the sine of 150? Well, it's a half. We're going to prove this expression here. Now they haven't actually specified use it, but it's smart to use it because you look at it, and on one side I'm dealing with thetas, and on the other side I've got half the angle. Of course, theoretically I could have used it using double angle results as well and changed all of the left-hand side, but that sounds like a lot more work. So let's sub in the t results. I'm going to sub in, they're all sines and coses, so again the denominator will cancel out nicely, multiply everything by 1 plus t squared, tidy it up, keep going, there we go, and yeah, it all comes down to be t. But in this case, I don't leave it as equals t. T is something I introduced into the question. I said let t equal this. I haven't answered the thing they asked me to prove. They asked me to prove it was tan theta on 2. So I just need that final bit and say, well, that is what I said tan theta on 2 was. And that completes the proof. The HSC one, they always, well, not always, but they usually give the option or otherwise, should you want to do it some other way. Usually the other way is going to be longer. They're giving you a hint. And they go this way. It's probably going to be the quicker way of doing it. So by making the substitution t equals tan theta on 2, we're going to show this expression here. All right, well, let's play with the left-hand side. Cosec and cot, well, they're the reciprocal of sine and tan. So I turn those t results upside down. Nicely, the denominators are the same for me. So I can add these fractions quite easily. I end up with 1 on t, which is the reciprocal of t. T is representing tan. Reciprocal of tan is cot theta on 2. So let's play with our t results.